Okay. Share my screen. Right. So yeah, hi everyone. Whether it's you joining live or you watch the session later on YouTube. So this is our Multimodal Weekly webinar series hosted by the team at 12 Labs. We've been doing this over the past year and a half or so. We'll be meeting on a weekly basis every Friday. And here's the topics that we discover on a weekly basis. New research in multimodal AI and foundation models. We have community members talk about innovative application in different verticals. We have folks talking about building their developer projects, right? Working with video and multimodal. And recently, in another attempt to get more people to become aware of our product offering, we have team members come and talk about right how to use our technology, whether it's in form of demos, guys, or in-depth tutorial. So for example, like why in the past I've been focusing on the researcher side, like in the most recent session, we have members from the marketing team talking about how to use a playground, as well as members from a research team talking about the mechanism of working with video foundation models. So for today's session, we have two members. So Manish is a product manager of the Embed API projects, and we have Hrishikesh on the developer advocacy side, who building different sub application, demonstrating the power of Labs API for developers, and they will together talk about the new release Embed API product that we launched into public beta last week. So this product has been public beta for a while. We get a lot of great feedback from developers like yourself, right, to make it I guess like production ready. And so yeah, we happy to announce that it came out in public beta last week, and Manish will walk over kind of the benefit of using multimodal embeddings, key features, the power of that, and then in the later half of the session, Hrishikesh will demo a real world sample apps that he has been spending over the past few days building on, leveraging Embed API and a few other technologies. So super excited to hear their thoughts on this topic. And since this is more like an interactive session, if you have any question, feel free to just raise your hand, and I surface the question into the speaker. But yeah, that's some note on the logistical session. So with that, I will stop sharing my screen, and I have to enable screen sharing for the speaker first. Yeah, Manish, you should be able to share the screen now.
Awesome. 1 second. All right. Can you all see my screen?
It still say, oh, okay, yep, now we're seeing it. Yep,
okay.
Good. Let's go.
Awesome. Thank you everyone for joining. I'm Manish, I'm a product manager here at 12 Labs. And thanks for joining on a Friday. I know last day of the week, everyone's looking forward. So we'll try to get through this within the next 45 minutes to 50 minutes. All right. So what we'll cover today, the overall session is divided into two parts. First is I will go over what are embeddings, the use cases, and then jump into the Embed API and the demo for it. And the second part is going to be presented by Hrishikesh, who's going to help provide the application that he has developed and demo it to you all on top of Embedding API. And I know there's a mix of crowd here, folks who are deep into the embeddings or technical machine learning versus also folks who are just new to this area. So I will spend a little time just going over what embeddings are, providing enough baseline understanding to get everyone on the same page. And then we'll jump into the actual API and how everything works. All right. So what are embeddings? In general, embeddings are just a numerical representation of the data, and the data can be image, video, audio, text. And when I say numeric representation, it captures patterns, relationship on what is shown in that, what exists in that particular data. And all of that is captured in some bunch of float values, which is understood by the machine learning algorithms. So in this case, this image is of a dog and a cat. When the embeddings are created by the encoder or the machine learning model, the vectors are in a high dimension space, and they are just projected into a place where machine learning algorithms can understand that dog and cat have legs and they breathe. Versus human, they have additional feature of speaking. So we understand it as humans, but machines don't understand it. And as a result, like we create these embeddings enable them to understand all of these characteristics and features, which are nuances. What are video embeddings? So video embeddings is just, as I mentioned, like it's one of the complex data type. Video is unique in its format. It's as it has image visuals, which are a bunch of images. It has temporal nature, which is every it's say 5 minutes video. The sequence of actions, the sequence of things that has happened matters in that 5 minutes. It also has sound. So sound, visual, and the sequence of action, all of that when you combine together can be has a specific meaning. And as time passes, that meaning can change. And not just the time, but also space. Where exactly is that particular person? So for example, if a person is running in a desert, and he runs for 5 minutes and then he finds, say, a water body because he was thirsty. Now he can rest. You understand there's a bunch of sequence that happens, and there's also context, like where exactly is that particular action happening? It's happening in a desert setting, and for how long did it happen? So there are a bunch of nuances in the video. As a result, video understanding is pretty complex research area itself. What are multimodal embeddings? Embeddings are just embeddings. When I say multimodal, it's just multiple modalities. Video in general has multiple modalities, as I just mentioned. Image, audio, text. When I say image, video is just bunch of frames together, but it has meaning, like the frames in a specific sequence for a specific time. It generates a specific meaning. And when I say multimodal embeddings, you can get embeddings for image, video, audio, and text. And for 12 labs, we have the 12 labs Marengo model, which is a retrieval model that can understand each of these data type and generate the embedding for each of these the input data. And on the right-hand side that you see, these are just float values that are being generated for each of these data type. Now, the unique thing or the benefit of multimodal embeddings is that all of these embeddings for multiple data types. If you, with 12 labs, you have all of these embeddings in the same vector space, which means you can do any-to-any search. So for example, I have this particular video of a horse running in between a crowd. I can do a query of saying crowd of men with a horse running or something, and then we will be able to capture that particular video segment from on the query side. Also, if you have an audio with crowd, noise of the crowd, and also horse, we are able to just use the audio segment to find all the videos that has that matches semantically to that audio segment itself. So that is the beauty of like having a multimodal model where all of the input are in the same vector space, enabling you to do any-to-any search. This is specifically helpful in RAG workflows. For example, you have multiple data types. And when I say RAG, for folks who don't know, it's a retrieval augmented generation, where in the if you're using LLM or AI in general, and you have a knowledge base, knowledge base can be an external knowledge base, and you have multiple data types in that particular knowledge base, you can store each of this data types in that knowledge base. And when you're trying to generate some content through the AI, you can find all the relevant pieces across image, audio, and text, in order to get the relevant pieces for your application, and then provide a more relevant and more high quality output as part of your application output. The embeddings from 12 Labs are generated using our state-of-the-art Marengo model. We are going to release a new model pretty soon, which is Marengo 2.7. But each of these modalities, when I say video, audio, image, text, across all of these benchmarks, MSR VTT, which is T2V, which is text to video, MS Coco is text to image, and Clotho, which is text to audio. Across for each of these benchmarks, the Marengo retrieval model is state of the art. It's also published through across a paper. So the entire report is available online for you to take a look at. And each of these benchmarks are on zero-shot retrieval itself. So I'm jumping into 12 Labs platform now. High-level 12 Labs platform enables customers to do two key things. One is retrieval, and second is generation. When I say retrieval, it is you store a bunch of videos, and you are able to get you are able to search the right moments in those videos. And when I say generate, it's video to text generation. And you can create captions, summarization of the videos, create data labels for your videos using video to text generation. Both of these tasks are powered by a specific model. The retrieval is powered by the Marengo model that I just shared, and the generation of video to text is generated by the Pegasus model. We are going to be focusing on the Marengo model specifically for this talk. And we recently launched Embed API. Embed and Search are both powered by the Marengo model. When the user inputs provides image, audio, text, the model processes that data and then generates the embeddings, and then gives you the user back those embeddings, which you can then use in your downstream applications. If we end up using search, we index all the videos that you upload, and we generate those embeddings, and we have re-rankers and the overall search algorithm that helps you perform search operation directly without you having to manage your search systems. And all of this is available through the API. Everything is developer first, and I'll be sharing a bunch of resources at the end for you to get started. For the embedding API specifically, as I mentioned, all the modalities are supported, all the major modalities in video, audio, image, and text, and all are in the same space, enabling you to do any-to-any search. The dimensions are 1024 float values, and the similarity metric is cosine similarity. So basically, when you're performing using these embeddings as part of your application, and you're trying to perform semantic search, for example, you're going to find the distance between the two embeddings, and you're going to use cosine similarity metric for that. What are the applications? So there are a bunch of applications. At a high level, the embedding applications can be used, embeddings can be used for hybrid search. When I say hybrid search, it is a keyword-based search plus semantic search. And when I say keyword search, it means it tries to, the keyword searches specifically matches exactly the words that you put in the query, whereas semantic searches enables you to find matches that have similar meaning. And we have seen from engaging with a lot of customers that hybrid search enables you to generate very high quality search results. You can also use embeddings for data curation. For example, identifying outliers, identifying the clusters of data that you have, also identifying what type of data do you have today for data curation steps in order to use as part of your ML workflow. Also, the recommendations, you can use these visual embeddings as part of your recommendations engine. Today, majority of the recommendations are based on item-based recommendations. Item-based and potential, and when I say item-based, not just product or specific item, but also some profile or user information is also used. But it's mainly just if John likes something and Mike likes something, Mike is similar to John, then Mike is potentially going to like that something as well. That's how majority of recommendations work. With embeddings, with visual embeddings or embeddings, you can significantly improve the recommendations as you are now getting additional signal because John can like something that is visually appealing, but you're not able to capture that information, like what exactly that visually appealing thing was. Now you can with these embeddings. The end user application, we have seen the embeddings getting used across all the verticals. Security, for example, to find you use a particular image of a security, meaning you have security cameras or any law enforcement agencies where you have security cameras and you're trying to find a certain event, maybe a man or a person or a vehicle is of interest, and you can use the image of the vehicle and you can find all the videos or all the captures that were captured through the security cameras using just that particular image itself. For marketing, you can use embeddings for contextual ads, so identifying right moments in the entire video and injecting ads which are semantically similar to the theme of the video or the theme of the scene itself. So, for example, if there's an emotional scene going on, you can input some product ad that resonates with that particular scene itself. And there are a bunch of other use cases, media as well, where customers can use. We are working with a bunch of media and entertainment companies where the embeddings get used to retrieve the right clips or the right videos from the entire video library, and then use it as part of the data curation or as part of a new asset creation itself. And all of these, as I mentioned, embeddings from 12 Labs are available through Embed API itself. These pricing is available online, so I'll not spend more time here. I would say the majority of when you look at other models that potentially provides you embeddings for video, and when they say video, it's basically clip based. When I say clip based, there is a clip model from OpenAI, which is open source model. Typically, video embeddings today is done using clip-based models, where that model is going to use certain frames from that particular video. Think about every 1 minute, there'll be one frame, and you'll be able to generate the embeddings using that. But the quality of those embeddings is not going to be great. The reason is you're just capturing one frame, one moment in that 1 minute frame, 1 minute in that 1 minute of video. Say you have 100 minutes of videos, so you're just capturing 100 embeddings for every 1 minute. So you are actually losing a lot of context for what happened in that particular 1 minute if you just capture one sample of that frame. So whereas from 12 Labs, we look at the entire segment and the entire video together, and also clip-based as well, which I'll go in a bit. We capture the entire full understanding of that 1 minute video, what exactly happened, which means there is temporal understanding and spatial. When I say temporal, what happened as part of the sequence of actions, but also the context, where exactly is the scene happening. So that is the key difference between 12 Labs embeddings and others that you may come across. For the API, and I'll go over this high level, there are two steps. One, you send the video through a Embed API task, and then you wait a couple of minutes for it to process, and then you perform a GET request to retrieve the embeddings for that video itself, and you get the video embeddings back. I'll jump into the 1 second. Sorry. 1 second, I'll jump right into this. Yeah. Okay, so the way the API works. Okay, so the way API works is we have the Embed API, and all of this is available in documentation as well. But we have the Embed API endpoint, and you can provide text, image, and audio as an input to the API, and then hit send here. And then we get the embeddings back. In this case, I provided some text embedding, audio embedding, and image, audio URL and image URL. You can also provide files directly as well. And then you see that you get text embedding back, image embedding back, and audio as well. And again, as I mentioned, all of these embeddings are in the same latent space. So you can perform text to image or text to video or image to text, any to any search, essentially. And these are float values of 1024 dimensions. Now, this endpoint is for image, audio, and text. There's a different endpoints for videos as tasks. You can send, you can use the video URL or video file directly. You can provide the clip length. And when I say clip length, it's between 2 to 10 seconds. So think about 1 minute video. Do you want to capture every 2 seconds of the video, like one embedding every 2 seconds, or do you want to capture up to 10, like every 10 seconds, one embedding? So let's say I have 10 seconds over here. So every 10 seconds for 1 minute video, which means you will get 6 embeddings back for 1 minute video, which is 10 for one embedding for every 10 seconds. Once I send the request, I get the task ID back. I use this task ID to retrieve the embeddings using get call on the same endpoint. And you see over here that I have, I get the embeddings back as in the segments object, and each, and each here potentially it was just one 10-second video itself. And that's why I just got one embedding. But if it were 1 minute video, I would have gotten 10 embeddings back for every one embedding. For one embedding, it's for 10 seconds. And you get all the metadata associated with that particular embedding request itself. For example, what the file was or video URL was, so that you can use it as part of your application or workflow itself. All of this is available via our notebook, which is Quick Start Notebook. And it is available through Quick Start Notebook through basically SDKs. You don't have to use APIs directly. All of this is available through the SDKs. And I just ran it. I'm not I'll avoid running it right now, but as you can see, once I run, like it's pretty easy. You import the 12 Labs. First, we install the 12 Labs SDK, which is for Python. We also have it for Node.js or JavaScript. You use your API key. You use your API key to create a client, which is here. And then you use that particular client to create the embedding request for the video using video URL or video file. Once that is done, then you can fetch the embedding back using task.retrieve. Once the embedding is received, then you can get the embeddings back like this. Same for image, audio, and text. You can generate the embeddings using similar way. For example, for image embedding, you can have the client. Once you initialize the client, then provide the image URL and the engine name. Engine name in this case is Marengo Retrieval 2.6. And then once you are ready to generate the embeddings, you can generate the embeddings. Here I've already generated the embeddings for audio, image, and text. You can see all of these vectors are generated, and each of this is again through the SDK itself. Once you log in, if you have already not signed up on 12 Labs, please go ahead and sign up. You can, you get up to 600 minutes of indexing for free, but also you can use the Embed API today. Once you have, so in this case, let me show you what exactly I mean. Once you have, once you log in, you can create a new, you can create an index, or you can use your default index. Once you're in the index, then you can upload a bunch of videos. Sorry, this is my video. Yes, you can upload a bunch of videos, and then you can use the search functionality over here to search across search in a specific index, for example. We also have the embed link over here. So if embed product, so once you click on the embedding and you select a specific index, we also enable you to visualize all the embeddings. So as I mentioned, you can use the this visualization to understand how how the data looks like in that particular index, for data curation, or just understanding what type of video content you have. So in this case, let's see. Yeah, so in this case, I have already generated this content. 1 second. Let me just refresh this. So there is a sample video mix, a sample index that I'm using here. And you can see that the cluster over here, when a bunch of green dots, these are basically embeddings. The original embeddings are of 1024 dimensions. We reduce it down to 2 dimensions using some algorithm, TSNE algorithm specifically. And now you can see these clusters. These clusters, when the dots are closer to each other, it means they are visually similar to each other in some form. So let's see what type of video this is. When I click on this, I can see this video is of folks dancing. Let's see if there are other videos similar to this. If I click on this one, so you can see this is a different video, but it's a similar action. And there are other videos. Let's see this cluster. This is also a dancing video, and these both clusters are very close to each other. Let's see this one. These are cooking videos. Let's see if these are all cooking videos. Yes, so this is a different video, but they're all clustered together. Let's see this. I'll just show one thing. These are all cartoon. Let me see where is this. Okay, so maybe what I'll do is I'll use this text embedding projection. So if I use soccer, I'm trying to find where are all the soccer videos. It gets okay. So when you see that orange dot, so it's hiding right now. So we'll fix that. We'll try to improve that visualization. But you see this orange dot is for soccer, which is text embedding. Let's see if these are all the videos of soccer. So you can see all of the videos which are clustered to each other, they are next to each other, are of soccer play. I can also see if I have baseball videos. Let's see where this gets projected. It's hiding somewhere here, I think. So it's all baseball videos over here in that cluster. And maybe there is, I think I already did soccer. Let's see. Football. And I think there is here. So all the football videos are clustered in this particular space, and that is the reason this green orange dot was projected over here. So you get the idea where you can now understand what type of data do you have by adding text, by associating text with the videos. In the future, we are also going to add image and audio as well, so that you can see that all of these embeddings are in the same space. As a result, you can do any-to-any search. Lastly, I have built this using our data set that is available online, where you can the recommendations app. So this recommendation app is vanilla app. It just uses visual signal only, which through semantic similarity. So let's see, and all of this is done using the embeddings. There are around 3,000 videos that are indexed. Sorry, not indexed, 3,000 videos that I generated the embeddings for, and stored it in the vector store, and built this recommendation app. So let's say this is a music video. I want to find all the videos similar to this. I click on this and I see there are a bunch of music related videos in this particular data set, which gets recommended. Let's say I want to find the scene. I want to find more videos like this. Then I can find a bunch of videos that are similar to this particular video that I selected. So all of this is just using the visual embedding only, but you get the idea that you can build a bunch of applications just using the embedding API. So just to close it out, the embedding API is available today. If you have not signed up, please sign up on the on the 12labs.io website. Once you are in, you can start using the the visualization using the sample index. But if you want to start generating the embeddings for yourself, you can go to settings and you can find your API key, and you can get started with that particular API key as well. And to close out, high level, as I mentioned, the platform is powered by two models, Marengo and Pegasus. Marengo is our retrieval model that powers our search and embed API. And then the Pegasus powers the generate API. And when I say generate, it's video to text generation. And the Embed API can take video, audio, image, and text files. And all of these are in the same space, enabling you to do any-to-any search. And you can also use the search API directly as well. That's all I had for today. I'm going to stop sharing my screen, and then I'll let Hrishikesh take over from here.
Yeah. Let me unmute Hrishikesh, so you can go ahead and start with your portion of the webinar.
Yes.
And Manish, in the meantime, there's a bunch of questions on the chat, so you can just review them and answer them asynchronously. That'd be great. All right, Hrishikesh, refresh your screen and do it.
Okay, so like as now we have understood about what are the various use cases or in what ways you can use the Embed API. So now we'll mostly focus on the demonstration and various use cases, how the embeddings can empower or power up the various applications. So here, as we are talking about the providing the user with the power of just like searching with the text to find videos, or providing the images to get the videos, or voice to get the visual like image or video or anything. So it can be anything. So a lot many things. And this is a kind of application that we will be discussing is any to any application where we are providing any modality and we'll be getting the relevant modality around that. So why more modalities we are discussing around the use cases and around the product is more the modality, more the power to the users, and more personalization it would be for the users for the more engagement. So let's have a look at the first of the some of the scenario use cases product, and then we'll jump to the demonstration. So this is one of the use cases which Manish also discussed about the surveillance. So how it can be used is, let's say, having a knowledge base created which contains all the CCTV footages, and also maybe the descriptions if there is available, all can be dumped into the knowledge base by converting with the help of Marengo 2.6 retrieval into the embedding format. And it saves a lot of time for an individual who needs to search around any accident or any critical path, or let's say that person needs to just identify some object, a big object, and can just provide a visual image to get the particular video segment out of that, or can just have a natural query. So there are a lot many stuff which can be built around this, and it actually saves a lot much of a time of the user. Second is like organization documentation archive assistant, so you can just comprehensively understand with the name itself is when you need to just, let's say, having a configuration, and there are like lot many documentation archive which has been present, and just let's say you need to configure something very internal tool which doesn't have any information around the internet, and it's totally in the organization documentation. So you can just the organization can just set up the knowledge base around that, just dumping all the Notion pages or any other documentation, converting into the embedding and storing it. So if I just wanted to search around how to configure AWS in this my application, so I can just get the relevant information around that in the text documentation plus the video if anyone have created about the troubleshooting or the configuration setup. So that can be retrieved and all the multimodality can be assessed with the help of that. So it also boost up the productivity for the user. And one more use case is museum guide assistant, as in the reason to add this one here and creating the UI for this one is um, providing the providing the response as per the preference of the user. So nowadays, if you will just go to the museum, there is an audio book or audio which has been provided, and you get a set of repetitive thing. How it can be enhanced as per the preference and the personalization to the user is if everything is converted into embedding, they can just query about any object or anything and get to know a very specific thing about that. And with the help of embedding and the knowledge base, they can get a relevant information too. So these were all the uh, use cases, and very diverse use cases, as in surveillance to organization to museum as a tourism part. So you can understand it have a varied domain use case which the product can be built on. And now we will be focusing on a very important use case, and we'll be seeing how it is being developed is the fashion assistant with image search. So we all know, as in various companies have till now integrated the reverse image search. But here we are discussing about providing the image and then getting the information from the embedding with like getting the particular video with the similarity, confidence similarity, even with the description and the buying link and all this stuff. So how it has been built is by using the vector database of Milvus and using the Zilli's cloud deployed on GCP. Here, Merengo 2.6 retrieval is used to the product catalog, the whole product catalog with the video, because nowadays various products marketplace are also having a reel and video explanation or just an output check. So whole product catalog for each product is being converted into the embedding and then stored into the vector database. Next is when the image is provided. So let's have a look and then we'll understand more. So we'll just directly go to the GitHub. So, okay, we'll go to the app first. So this is the app. Here, we'll skip the adding to the knowledge base. Here you can understand with this is it is connected to the collection name, which is 12 Labs collection dress 6 and having a total video segments of 28. So this is just to showcase the connection and all the data which has been present in that. So let's say I just need to search around the knowledge base. So I will just look for the image, let's say this t-shirt, and okay, need to reload, I guess. So as soon as I provide the image gets converted into the embedding with the help of same model, Marengo 2.6 retrieval. And as per that, it searches. So let's give this one. Okay. So here my image got loaded. I need a number of result as 2. As soon as I search, here I get the video particular with the same that men require some serious man with the same and with the similarity score, also with the title, with the description. Here is the product link. Also it provides the seconds, as in which second it particularly showcases that product. So uh, as in description, and here is the product link. So if I just go to product link, I will just be redirected to the shopping portal. So this is like one of the use case where the two-way retrieval is being used, because if we just see to the traditional way to get the feature or the extraction of the feature from the image and then searching from the vector database, at that time we need to use heavy model with the like torch model, let's say resonate and all, to get the feature vector and all. And here we get a very quick embedding, and with the help of the better understanding with the video, it fetches the video and also the information about that. So if we see to the code how it is been built, so we'll first see how the embedding is pushed into the vector database and how the connection has been done. So for this is the 12 Labs video embed GitHub repo, and here you can see yeah. So here you can see this is just a normal collection with the connection with the 12 Labs API key, with the Milvus DB name and URI and token. After the connection, here the data which I have prepared for the product catalog is product ID, title with description, link, and a video URL which has been stored in the GCP Google storage. So all this product catalog, for the sample I have taken the 4 videos, and I just provide it to generate embedding here. So here let's go to generate embedding, and as soon as we get here, it is so easy to create an embedding. We just need to provide the engine name and how I'm iterating over the video URL which is been there. It is the application is very much focused towards finding the video, and all other datas are in the metadata. So it creates the embedding here, and after that I just append it to the dictionary of in a format which I need to store it in the Milvus. So I just uh, here with the insert, I will just append here collection.insert data, and here my all the data gets stored into the GCP. So if I just and showcase, yeah, how it has been stored. So here you can see there are like for dress 6. So for dress 6 collection, yeah, this one. So here in data preview, you can see all the embeddings are stored, and from here it is fetching. You can see the 28 as in segments which are there. How 28? I have taken like by default as in 6-second segments, because the video length was smaller for a demo. So each 6 segments, 6-second segments it created for the embedding, and then it is pushed. If I just so this is the way. This is the simple way how the embedding is created. It just like simply So simply with the task creation here, with the providing the engine name and iterating over the video URL, and here the insert embedding. And yeah, this is the whole insertion. Next, if we go to the model, like how it searches. So here we came, the same code you will get to see as in configuring the connection, and after that field with the dimension of 1024 it works. Then the collection name and all the Milvus connection you can see. This is just a CSS part, so we'll just skip that and we'll focus on the main. So here generate embedding we have did before. So image embedding. So what is happening is when I provided the t-shirt photo, it went to here, and after that with the help of the same, but here the param is image file, and the image file is provided, and then in return I have got embedding float, the whole embedding vector. And as soon as I get that, I will just click from here. It called 12 Labs client features image embedding, and yeah. So here, as soon as I got this, I just search for it with the Milvus client dot search with the cosine as metric type, and here is all the details that I got as title, description, link, start time, end time, video URL, and the similarity score as a similarity score by like multiplying with 100 to get it into the proper percentage format. So you can understand like this whole the creation part, and the app is developed in the Streamlit. That's why there are other codes, but you can see there is this two utility function only which has been used. One is for the generation and one is for the insertion, and third is the search similar videos. And your like search similar as an type of application is ready here. We'll also look to the RAG type application, a RAG where the LLM is also attached to the architecture, so that we are not only restricted around like providing only the visual things, but we can have a conversation with the natural query. So let's see this demo. So this demo is the same fashion AI assistant, same vector database, but here I have connected it with the OpenAI model for the natural query, and you can see uh, it it fetches the details as per that by understanding that, and provide more uh, text and understands your text, and as per that provides the reasoning for it also. So let's have a proper look. So here you can see I just wrote black leather jacket for women. So it provided a bit of a description from the embedding which it got, and then black leather biker jacket here with the similarity score of 85 and V1 store, and also the other similar videos and the content or a product which had something like black. So let's have a look at the demo, how it is created, and also we'll understand the whole architecture also. So it is the updated version of the previous app which we discussed. The same vector database as Milvus, Zillies, with the embedding as Marengo 2.6 retrieval, LLM model as GPT 3.5 Turbo OpenAI, and it has been deployed on Streamlit Cloud. So let's have a look at the architecture first, briefly, and then we'll look at the code. So how it works is, let's have a demo first. So loading. Okay. So let's say what should I write? Okay, let's write I wanted to go for a wedding. Please do provide bridesmaid dress suggestion. something like this. So it is finding as per the keyword. So it's provided for the upcoming wedding, look no further than the Sakhi. So it, as per the system prompt, it is behaving as in fashion assistant. So as per that, it is providing the collection is designed to meet all your bridesmaid and all the other stuff. And if I just go to the product demo, here you can see with the similarity score of 76 with the wedding season around the corner and all the description which is there in the embedding as per that. And also we got the video also. Here, if I just go to view on store, I can be go to the web page where the buying and selling can be done. So where is that? Yeah. And also like there are other suggestions too which got. So if I just write around like the same one which I wrote before, black jacket for women. So let's see. So I got a black leather jacket, is a versatile and iconic rocker look and all stuff. And here I got the similarity score as 79.24 with the video uh, or the reel of that and the link. Also, I've set the similarity score as a result to fetch as a relevant as 3. So it provides the 3 catalog. So as per the black and all, the other products are also been provided uh, with the link and all. So let's have a look about around how this is developed and how easy it is to develop the app. So I will just go to the architecture now. Yeah. So what is happening? I have provided the JSON before the of product catalog. What happened is data pre-processing and all other stuff and storing it to the temperatures, the temporary storage. After that, connecting to the 12 Labs client and then making use of the Marengo 2.6 retrieval to convert it into the embedding and then using the vector processor. And after that, in the database system, I'm storing it in 1.24 dimension and also storing the metadata. Here in this case, the text embedding has been done for the interaction with the LLM because the interaction will be done with the text uh, and metadata is stored. After that, in the main Streamlit application, what happened when the user provides the query in the query processor? Okay, as soon as the user just interacted with the chat UI and get the query processor, here again the embedding is used to convert the text into the embedding, and after that embedding is used to get the relevant information from the vector database. And as soon as like I got the relevant information from the vector database, it is sent to the OpenAI model to frame it in a proper format. Like as in if we just go to the basics of retrieval augmented generation. So after providing the text and converting it to the embedding, and after it fetches the relevant information about that, as I searched for the black jacket, after the embedding of black jacket statement, and it retrieves the information, and this LLM, like as you saw, it provides the concise response of that, and then it showcases. So cloud storage is for the database only. So that is just the additional part. So this is the whole architecture which can be followed for any application which you can think of, which is around drag and around you making use of the embedding for any modality. So this one is just for the front end part. So as I told before, it is prepare on Streamlit. You can just go to the GitHub page and you can just set up on your local or Streamlit cloud, and you can just change the Milvus connection and the database, and it would work for you, for your use case. If we just see to the code a bit, so we'll just see the main utility. So here, here the code for the conversion of the JSON to the embedding is not there, directly using by the help of the connection with the Milvus. So as soon as there is like ask about fashion product and all the st.session and all that stuff, as soon as the response is provided, it sends to the get rag response. So we'll just get to the get rag response function utility. Okay, so this utility, what it does is, as soon as the question which has been asked by the user, it sends to the utility function to embed text. And what is happening in embed text is, we are making use of the embedding API here, where we are converting the text of the query into the embedding and then fetching the relevant information from there. So as soon as we get it in the question embedding, the collection.search providing the data as a question embedding, limit as 2, and output fields as a metadata, and other stuff as in what are things which is needed to be appended. And this is now we need to set up the LLM model. So setting up the LLM model, we need to have a system prompt. So I just added as a you are a professional fashion advisor and AI shopping assistant, provide stylish, engaging response about fashion product, focus on style trends and all other stuff. So, and for the user one, the question I have asked here goes here and with the context. Here after that, here I've used like GPT 3.5 Turbo with messages as in there, and after that it provides the response. And yeah, it was that easy only. Like after that, all the stuff which you can see is just a rendering the response and providing it to the UI. The main utility function you can see, it's only in this get rag response and the embed text. Yeah, so you can just think of any product or rag which can be created, and with the help of the this Word file, you can just build the system with that. So we are at the end now of the discussion. I hope like you got all the ideas about the various product that we discussed, about the various use cases and the demo. Yeah, thank you.
Awesome. Thanks a lot, Hrishikesh. And for the audience, thanks a lot again for participating. I saw that you just want your question in the chat. So I hope Manish, help with the response of all those, and you got the idea of how a solution works right under the hood. So yeah, I think I share a bunch of relevant links on the chat, right? Whether it's the cookbook to get started, the blog post, as well as some of the, the repo and the Streamlit that Hrishikesh has been displaying on, the webinar today as well. So yeah, super excited to have you give a try about API and view interesting application on top of it. And yeah, we will have a Discord where you can stay up to date with upcoming webinars and future product announcement. Yeah, so the recording of this session will be available probably by mid-December, I say. So yeah, I started to have more session talking about some new release that we have in the future. So yeah, thanks everyone for making time today, and I hope you have a good rest of your weekend. Bye guys. Thank Rishi and Manish for preparing.
Thank you. Bye.
Bye.